Hello there, I am Antonio Limena from Duesi Software, and welcome back to this second lesson of the basic ProSAP course. In today's lesson, we are gonna focus on the modulation of the ground stratigraphy and the modulation of some particular foundation types like foundation piles in order to perform a geotechnical analysis. And also we're gonna perform just the linear dynamic analysis on the structure in order to obtain executive drawings, calculation reports, and metric computation. We're going to start from this model that has been sent to me. And first of all, I know that you have some issues with the material archive because it results empty on your computers and probably is an installation problem, but we can resolve it in other ways. First of all, I'm gonna select the link with the language. I'm gonna set English. Okay. And second step, I'm gonna delete all my material archives because I already have the default materials. Oh no, okay, sorry, it is already empty because it's your file. Okay, so in order to import a material archive, you need to have this file that I'm gonna send you with this video, and that is on a CSV format, is something like an Excel file, and you have to go edit, import export archives, select materials or whatever archive you want to write or to read, so to import or to export, because you can also use this command to export archives and then import in other models. In this case, we want to import the material archive, so we can go read, and then you just have to find it. I have it on the desktop. Okay, you just need to select the folder. You don't have to select the real file. If I click on desktop, it should automatically find it and import on the model. Now I can close. We don't receive any kind of warning. Just when we click on it, it's done. So I can close this. Then if I go on materials, here I have my full archive of pre-ordered materials. This is an Italian archive right now. I will send you the English one maybe. But for this lesson we're gonna work with this. Just it's not that important. We're gonna assign one material to everything, and then we will go on. So first of all, in order to assign the material, we need to go edit, so the command to open the properties of the element, click on an element, and then on the material property select the one that we want. So let's say the first one is okay. As I said in the previous lesson, once that we have our property set, we need to click on this. Okay, just activate also instant apply. So with this activated, so the foreground is light blue. It means that whenever you change something, this change is automatically applied. So this is quite important to have activated. Otherwise, you can forget maybe to click apply, and it could be a problem. So my suggestion is to keep this always activated. Once you change something, okay, let's say that material is number 2, the property that you change are going to be highlighted in black, it's going to be bold, and then you click on this set properties and apply. Click it a couple of times to be sure that the program received the command. Then you can close this, select everything basically, and with right click Okay, no, everything no, because to assign properties, you have to assign it to other elements that have same, let's say, properties. In this case, I selected all, but nodes doesn't have the material property, so it doesn't work. So I'm gonna use a filter, exclude the nodes, and then with select all, I can select everything except for nodes. So with right click, yes, now I have more options. In this case, we're going to use assign material. With assign material, the previous settled material is now assigned to everything. In fact, if you use edit on a different element, previously I clicked on this one. If I try with this one, I can see that now the material is number 2. Same for beams and for sections. For example, I see in this file from SolidView that there is a reverse T section on the upper beams, and probably this is wrong. I don't know, but I'll use this as an example to also change section, even if you probably already know that from the previous lesson. But let's have a recap about that. So as before, I can go edit, select an element, change the section. Okay, this is the only section we have. So we go on structures data, sections, and we create a new one. Let's say we have a regular rectangular section with base, I don't know, 50 and height 30. Let's say rectangular beam. Okay, whenever you create something on the archive, you have to click apply in order to apply it and not lose. Because if I go on an empty slot and like this, I create a section. Okay, and then instead of clicking apply, I move on another slot. The previous slot is now empty, so until you don't click apply, it doesn't save anything. So we created a section. Now I want to apply it only on the upper beams, so I can go view X view and with box select only beams. Right click, assign section, and now we can see. Okay, something went wrong. Sorry. Okay, probably because I didn't settle the right section. I just created it. So I go edit, section number 2, already saved. This command that is set property. Now I can close. As before, I go on X view, box, select all topper beams, right click, assign section. And now we have a better model, let's say. I don't know what your intent was, but I suppose that this kind of section is not meant to be on the upper beams. Okay, so now you should have the material archive correct, and we can go on with the description of the ground. So from there, we are going to move to geotechnical analysis. First of all, to perform geotechnical analysis, we need to have in our model foundation elements and not boundary on nodes. So we are going to delete these elements, these nodes, and these link elements between nodes and code 0. So how to do that? I can go X plus as before. I get off the exclude nodes. Oh, sorry, I'm back on Italian. So box from right to left and cancel. Okay. Now we need to set the foundation property for all the elements on the quote 0. So edit, go for an element and foundation bottom face. Okay, click on this, set property. Once again, we can go on view X plus, exclude nodes, and with box select all elements. Right click, assign foundation. I will say, but okay, we can also go for assign reference. And now we can see that the color of all these elements changed. Okay, now we have the foundation beams correctly with the correct property. Now we are going to insert some special foundation elements like foundation piles. For this kind of elements, we have archives as for material and sections. So on structure data, we can go on foundations, and here we can find some kind of special elements like piles and plinth, and also combine the technologies like plinth on pile. In this case, for plinth, we just have geometric properties to describe the plinth. Instead, when we're talking about piles, we have more properties other than the geometric ones. So, first of all, we have to define the diameter, the length, elastic modulus, which of course should be the same of the material, because you cannot assign the material to the pile, because the pile later is going to be assigned to the single node, and the node has no material. So the only material basically properties that we need are elastic modulus and specific weight that we are going to insert there. Then here we have the pile mathematical model that basically is a kind of stratigraphy in which we insert quotes and the values for horizontal and vertical Winkler values. Of course, you can insert rows and remove rows to modify this thing. And here you have some different options, like especially for boundaries on the top and bottom of the pile. This bottom here is used in alternative to this stratigraphy to create a linear, how to say, it's just a linear increase or decrease of the Winkler value for horizontal and vertical Winkler. So here K0O is the horizontal value of the Winkler at the starting at the top of the pile. This is the coefficient of attrito that defines the decline of the K value, and this is the vertical value for the Winkler K. But usually this is not used that much. It's better to use this mathematical model with the full stratigraphy. So this is all about the pile basically. In case we have some plinth on pile, this section of the window are going to be active, and here you basically have to insert the geometrical properties of the plinth. Now we can go OK and apply. Each time we do this basically. And okay, we can close the archive, and to assign it to the nodes as before, we go edit, we click on node. Okay, now we cannot click on node because I already have exclude nodes from the selection. So edit node. foundation, and here we can insert the foundation. Note, pay attention that if you apply a fixed boundary condition, the foundation is no more available. So we have to, in order exclude the fixed boundary condition and then insert the foundation that we can choose from the archive. We can insert here a pile. Okay, set property. Okay, let's say that I want here a pile and here a plinth. Okay, let's set the plinth. For example, we are going to assign the plinth to all the right structure and the pile on the left structure. So view X plus. This time I want to select only nodes, and so with box I'm gonna check all nodes. Right click, assign reference. Then with edit, I go on the one with the pile, set property, box, select all nodes, right click, assign reference. Okay, now you see that when you have boundary condition directly on nodes, you usually have some triangles that are indicating which kind of degrees of freedom are locked. In this case, when you assign a foundation element, you have a small red circle around the node that tells you that there is a foundation element assigned to that. If you go with solid view, you can effectively see that. Usually, when we work with different kinds of foundation, like this case in which we have beams and piles, we have to decide which one of them, usually piles, supports the measured amount of load from the structure. So in order to tell this to the program, we are gonna edit the beam and assign to it a very low value of the Winkler factor, like 0.01. His stiffness to the ground is very low, and the almost total amount of load from the structure is now supported just on piles. This is important not to check out the foundation because in this case they still works on as foundations and thus does not load further the piles. Okay, now I modify this value for this beam, and as before, I have to assign this property to other foundation beams. So I can click this. To select all foundation, I can go property and select foundation beams. Okay, now we see that all foundation beams are selected. Right click, assign reference. Okay, and then if I check other elements, we can see that the K-soil is the same as we set it before and is very low. Okay. Okay, so now we can go on and we're going to define what's the stratigraphy of our model. In order to do that, we have to go structure data, geotechnical analysis, soil definition. Okay, here you can define the stratigraphy, and in particular you can define more stratigraphies collected in archives. So it's the same as sections and materials. Even there you have archives. In particular, these commands are for the single archive, and these commands are for the single stratigraphy. So you have different archives. In each archive you have different stratigraphies, because in the same model you can use different stratigraphies between different elements. Okay, so here this is the part of the window in which you can see the stratigraphy. With these commands write down, you can insert a layer. With this command on the left, you can insert a top layer, and with this one, a bottom layer. And with this one, you can delete the layer. I'm sorry that this part is only in Italian. It has no translation in English, but I think it's still quite easy to use. So actually, we don't have any kind of stratigraphy. Here you have a database of soils that you can use that are already pre-compilated with some properties. And in order to use that, you have to grab and move and drop on the top window, like that. So let's say that we want to use these three kind of soils. I have to take them from here and move on the top window. Now I have to define different layers, so I can add two, three of them. Selecting them, you see that there's no visual highlights, but you can read down there that we are clicking on layer number 1, layer number 2, and layer number 3. So, of course, with this parameter, we can modify the depth of the layer. Let's say that we have 5 meters for the second layer, 3 meters. I really don't know. Okay, I'm just changing numbers. And 7 meters. Okay, let's say that this is our stratigraphy. And then I want this kind of soil here, this here, and this one down here. Okay, so basically you have to add stratigraphy. Now you can see that with this command, okay, you add a layer on top of the selected one. If I click on the number 1 and I go bottom, exactly, it insert the new layer there. To delete, I can click on them and then use this command one. Of course, the command is giving you a warning. You can say just yes, as before. Click on the undesired layer, delete, yes. Okay. So let's say that this is our final stratigraphy. We can save now that. As you can see, for each kind of soil here on the right, you have different properties. They are pre-compilated based on this archive, but of course you can modify it if you have different parameters, basically. And if now we are still working in the same archive, let's say that I want to add a new stratigraphy. I can use this command, so new stratigraphy. And now you can move between the first and the second with this menu. Okay, now I go a bit faster. Let's say, okay, same kind of soils. I add 3 layers. The first one maybe it's deeper. Okay, maybe too much. The second one we can use the same. Once again, I'm just using random numbers just to divide, to recognize the layers. Okay, I can move this here, here, and this here. And now, basically, we have two different stratigraphies in the same archive. Now we can save it. When you save the archive, it's going to be saved as an str file. This is the extension of the file. And it will be placed in the data folder of the file. You can, that's just the same name of the file. The important thing is that you don't change the extension. We can go save, and then we can close this window. Save, modify is yes. Okay. Now that we defined the stratigraphy, we can use the geotechnical module to calculate, first of all, the K-Winkler value for the foundation elements. So previous we modified the K-Winkler value manually, but if you want a more precise, let's say more rigid value for this parameter, you can use the geotechnical module. And to do that, you can go structure data, geotechnical analysis. Okay, so the command is winter K evaluation. To use that, you have first to do a check structure data. Okay, I don't know which kind of warning is that, but you can just click OK. So let's have another check structure data. Okay, this time we have no warnings. And now you can go on structure data, geotechnical analysis, Winkler K evaluation. Okay, let the program work, and then you'll see this new program that is the geotechnical module. Okay, basically here you can calculate with this command the K-Winkler. Also that program is only in Italian, but there's not too much to do in there, so there are a few commands that you can easily use even if in Italian. Here we have almost the same commands as ProSap to select or to edit properties. If I click this, I can go on the property of the element. Here you can see how the foundation impact on the underground soil. This works, of course, for superficial foundation and also for deep foundation, like that. Now we can go on Calcolo, Costante Winkler, and we can do that also for superficial foundation and for deep foundation. They are two different commands. So let's use this one first. When you see this string, tutti gli elementi risultano correttamente calcolati, you can just close this window and then do the same for Costante Winkler fondazioni profonde. Elaborazione completata means that we are fine, we can close that. And then when you use this command, it automatically update the values on the original model on ProSap. So now you can close. It asks you to save basically. Of course, you can say yes. Probably you should use this save up there before closing, but it's not a problem. You can just say yes on this warning window. And then if you go check the elements, you can see that the K-soil vertical and horizontal, so the Winkler parameter is modified and it's exactly the same that the geometrical module calculated for us. Okay, now that we defined everything about the geometry and the stratigraphy of our structure, we can move on. So we go on context, check structure data in order to go on the load assignment context. Here, as I already showed you in the previous video, you can find the main load cases that needs to be filled with the generical cases. So here from generical loads. Here from load data, you can define the loads on the archive, and but we will come back on this later. And first of all, you should go on load cases. And okay, here we already have one load cases defined. What we can do is go load data and load cases help. Here you can add and delete load cases, so we can basically reset our archive of load cases. We can delete all and then add all typical action on structures, so GK, QK, etc. So from static cases and seismic cases that are defined by this AK. We can go there, same, okay, yes, we want to replace them. Basically, because I clicked 2 times, yes, it's not a problem. And we can close this. Okay, I just forgot something because now I wanted to show you how to insert pressure load for the soil. So ground pressure in either in static and dynamic conditions, so either on self-weight and either under seismic activity. In order to do that, we need to have some wall elements or panel elements that are needed to distribute the pressure load. So we go back on input data. Okay, now to work, I prefer to set the wireframe view. And okay, let's suppose that this wall here is underground. I can do something like that. So we go on D3, or let's say we can either use panels, okay, instead of the free element. It's basically the same thing. It depends what you prefer. If you have to verify also this element, okay, we have to use the free mesh by 2 points. I think in this case is just okay. So for this, I think I will use just this left structure as example because it's quite easier. So I will hide this, display hide. Okay, and now we'll just focus on this one. We need walls, so basically we go on D3, mesh by 2 points. So I can click here and here and go OK. Okay, I should have modified these parameters, the number of parts in length and in height. Actually, the default setting is 4:4. I think it's fine. Maybe it would be more appropriate to have a better discretization on X, in this case, on Y. So on the length, by the way. So I go on this command, click here and here. Number part E, let's say 6, and go OK. Okay, now it's just quite a better mesh. Before doing all the rest, I want to check the material and the thickness of these elements. In fact, by default, the thickness is 10. Let's say that the thickness is 20. And the material, I'm fine with the first one. So I set the reference. With property, I select all the walls. And then with right click, I can assign reference. Now, if I go edit, okay, they're all 20 centimeters. Now that the reference is already assigned, every element that we are going to create with this command is going to have the same properties. So once again, the free mesh the free mesh by 2 points, click and click from here to here, and we can do that for each wall. Okay, probably for these litter walls, I should have placed a different input, like no more 6 the subdivision by the length, but maybe 3 are just fine. Yes. Okay. Okay, let's say that this is our structure. Now we have to, as I already showed you, we have to subdivide the two elements by the nodes of the mesh. So in fact, if I go split up view, we see that this element, the foundation beams, are not subdivided by the nodes. To do that, I can just go on context, check structure data. The program will say to me that there is this problem. Perhaps requires additional inspector, always say yes. Okay. And now I can click not divide, but intersect. Quindi splice the elements with the nodes. Each time I click, a piece of beam is subdivided by the nodes. So you have to click several times. until you see that is everything fine with columns, with beams, etc. Okay, now we should be okay. We go back again on context, check structure data. Okay, I think we can ignore this warning. Process completed, okay. And then we go back again on load assignment. And then in load assignment, we can go define the load cases. So we go on load data, load cases, we see what we already have. We already have one load case for the self weight, and we can use load cases help to create all the typical action of structures. So not only self weight, but also variable weights and seismic weights. We got that. We can say yes to replace. Okay, it should ask if we want to use the dynamic seismic actions. So, okay, let's check load cases. Okay, we already have one. I think this could be because we have a wrong. Let's go on input data preferences. Normative regulations. Okay, so I see that you set the DM96. Uh, I don't know why. Basically, if you use the DM 2018, especially there, and you go OK, yes. Now, if you go delete all and add, okay. Now it asks me, do you want the software to use seismic dynamic analysis for seismic forces calculation? We say yes, otherwise the software is going to set the static seismic analysis. So we say yes, and okay, don't worry about that, we're going to fix it later. If we go on load cases, we can see we have the self weight, and then we have the seismic dynamic. To have the variable weights like that, we have to model some horizontal plane elements. So slabs, I mean, the correct term is floor panel. Okay, these elements triggers the auto definition of the variable weight. It's not. We can go alone also without that. It's not a problem. Or why not? Okay, let's just define some of them. Let's go this. We go OK. And then with the right click. Okay, now you see that this midline in the floor indicate which direction the floor is basically in which elements it distribute its weight. So in this case it's on this wall and this opposite wall. But we have only one line. It means that the only nodes that take the load are the external ones. If with the floor selected, go right click link element, modify topology for number one floors. It means that the software modified the topology for this floor selected. We go OK, and we see that now we have several lines, but in particular one for each couple of nodes. This means that now our floor is well connected to the rest of the structure. Okay, now we can go. We can go again on check structure data. Okay. And on load assignment, if we go load cases help, we can delete all, add all, yes. Okay, and in load cases now we should. Okay, we just don't have variable weights. Not anyway. We can go on about that. It's not a problem. You can also you can ever add that manually, basically. If you go cook double click apply. Now you have one. Okay, so the command helps you in the automatical generation of the load cases. But basically, if it doesn't work or if you want to do that by your own, you can just move to the next slot, select seismic action, static seismic action, dynamic, click insert angle direction, where 0 is the x direction of the global coordinate system, 90 is the epsilon direction, and here basically you can set your load case, go OK, and go apply. Now I delete it because we already have it. And we can go on. Okay, now I want to show you how to apply the basically the soil pressure on the structure. So, to do that, we can use an automatization that ProSap gives us, that is used basically to create later the combinations. We have to insert two kind of pressure load on this structure, the static one and the dynamic one, so the seismic one generated always from the ground. For the first one, it's quite easy. Okay, now I want to hide the floor. Yes. Okay. For the first one, so for the static, we have to define on load data generic load pressure load. We have different kind of pressure loads. There are uniform pressure load and variable pressure, not uniform, so variable pressure load. For the static soil, we have to use this. And here you can, of course, insert the static soil pressure, the name of the load. You have to insert, as you see by this image, you have an initial quote, a final quote, and you can insert an initial value and a final value for the pressure. The software is going to automatically fill the linear value variable on the height. First of all, so you have to check. Let's go. Okay, apply. First of all, you have to check which is the quote of the topper node, let's say, of my structure. In this case, is 280, and the basic is 0. So we go back on data generic, and on the static load pressure, we can go quote initial quote 280, final quote is 0. Let's say that the pressure initial is 0 and the final pressure is I don't know, 10. And then we have to set what is the reference point position. Okay, so this is quite a crucial thing to understand when we talk about pressure loads. Because the reference point position defines the direction of the load. In specific, the load is gonna have the direction that goes from the reference point position to the element in which the load is applied. The load is always orthogonal to the element, and I repeat, the direction is from the reference point to the element. I'm gonna show you an example. Okay, let's say that I'm gonna insert the reference point internal to the structure. Usually this is quite a good strategy when we talk about static soil load. Okay, once again I have to go out. I need to check a moment which are the coordinates. So if this is 0, 0, 1665 on X, okay, 0 of course on X, so I can put X 300 and Y negative 900. So we said 300 negative 900. General load X 300 and Y negative 900. Okay, so now we have our reference point internal to the structure. And okay, we have to create manually a load case to insert this. And this load case is going to be of the kind generic live load action. No, sorry, of the kind GK, so generic dead, dead load. Fully defined is fine. We go OK and we go apply. Yes, okay. And then we define the load case and we have to insert the generic load in the specific load case. To do that, we use the edit command and we click on an element. I remember you that in the load assignment context, when you use the edit command, instead of having the property panel on the right, you are going to have this window in which on the left you have the generic load that you defined before, and on the right the load cases in which you have to insert this generic load. So insert the static load pressure here, inside the correct load case, do apply and set reference with this button. Now, okay, I already activated this command for view load case, quindi so you can see the load applied to our structure. Now, to apply to every other element of our structure, every other wall, we can go Property, Walls, OK, right-click, Some Reference. Okay, with this command Some Reference, you add this the last generic load that you applied to the already present loads. In this case, on this specific element, we already have it and we summed it once more. So basically now we have a double pair load only on this element, as you can see. So I can go ahead this one. In fact, I have to take one out, apply, and now we're fine. Okay, let's talk about that again. In the generic load, I have to define this. The pressure has to be negative, because the reference point position means that this load is going from the reference point to the applied element. In this case, the reference point is internal to the structure, so with a positive sign of the load, it means that it would have been from inside to outside. Let's have a try. So if I cancel the minus, I go OK, apply. As you can see, is exactly the opposite. So I have to go generic, I have to insert the negative sign. This is better than have a positive sign, because with a positive sign I should have generated 4 different generic loads, each one with a different reference point position. Placed outside the structure in the specific point. With this way, I can define just one with the reference point internal. So this is it basically for the assigning and application of the static load for the soil. And now we're going to do the same also for the pressure load generated by the soil in seismic condition. So first of all, we create a generic load. This time it is uniform, so we're going to use the uniform pressure load instead of the not uniform. So double click on it. Let's call it ATK because it's the same name as the load case in order to remember it. ATK seismic. we can define a pressure load, and the strategy is the same as before. So we're going to put a reference point internal to the structure, and we are going to use a negative value of pressure. So last one, I think, okay. And for the reference, we're setting 300 less 900 and Z1. Okay. We go OK and apply. This time we don't have to assign it to every element of our wall for the same load case, because we have to create 4 different load cases, one for each direction. So we go on load data, load cases help, add pressure of soil if in seismic condition ETK. The program is going to ask to apply loads to visibility free and panel elements. In this case, it doesn't change anything if we click yes or no, because in order to do that, you have to call the generic load with a specific name in order to use an automatism, but I prefer to show you the manual way to do that. So we can click no, close this, and if we go check load cases, on the end of the list, we'll have 4 new cases. So ETK, soil seismic thrust, overthrust, direction positive alpha 0, it means direction X, negative alpha 0, positive alpha 90, negative alpha 19, and we're fine with that. Now we have just to assign the same generic load in these 4 different load cases based on the direction of the wall. Let's do that. We can go edit, click on this. So in this case, the load must be assigned on the x direction positive. So we are going to bring this into the 11th load case. So direction positive alpha 0, so x positive. We go there, we go apply, set reference. Now, as before, we can go filter only free, view from the top, and with the box select all of these. Okay, it was already all selected. We select all of these, right click, assign reference. And now if we move here, okay, we'll see that we corrected, applied the overthrust on the wall. And now basically we do the same for each other region. Let's see, okay, we don't have to disturb the other static load. So well, sometimes just check also other loads. And okay, now we can move on the other walls. Click here. We have to apply the load in the negative direction of the y axis. So direction 90, sorry, negative. So the load is always the same, negative direction, apply, set reference. Once again with the ZView box, assign reference. Okay, we still have the previous one. Seems everything is good. So again, edit on this wall. Here we have to insert in the load case x direction negative. So alpha 0 negative. Apply, set reference. View ZView box, assign reference, and then before checking, already doing on this one. So this is the positive direction of the y, so alpha 90. Alpha 90 positive, apply, oh sorry, I have a double click. Apply, set reference, view from the top. Well, I forgot this part of structure, but it's not important right now. Right click, assign reference. Okay, now I can check if everything is fine, and it seems so. Perfect. These are our static loads, these are our dynamic loads. So pressure for the soil in different condition, triangular one for the static, and dynamic regular one, uniform ones for the dynamic. As last thing, before launch analysis, we have to create combinations. Basically, we use four different kinds of load cases in four different directions in order to let the program combine them with the seismic actions correctly and automatically. So now, if we go on load data combinations, this is empty. As usual, we go on general settings. We check for every case, but in this model there are no variable loads, so it's not important to that in this moment. And we can create seismic load combinations with this button. Now, these are the 64 combinations generated by the software. We can see that for the first one, for example, we have the self-weight, the dynamic load so the seismic dynamic load in direction alpha 0 negative. Based on the Italian rules, we also have the same dynamic load seismic in the orthogonal direction multiplied by 0.3, so the 40% of the action in the orthogonal direction. And then we can see what other kind of loads are applied. The static one, basically, so the static pressure load for the soil that has been inserted inside this load case. And then we add the one factor for the load case 12, which is the ETK, so the soil dynamic pressure in direction negative for alpha 0, so in the direction x negative. That is the same direction of this load, which is alpha 0, but with a negative factor. Same for the load case 14, that is 0.3, so the same factor as this one. This is positive because the load case already count is in the right direction, the negative one. This is negative because seismic load case is just positive, and you have to so the program is considering it on the opposite direction by the negative factor. And this is it. So you can just check if this works for every combination, but it should be. So let's say combination 10 randomly. We have negative for alpha 0, so x, and so I expect to have 1 on of the static load, of course, and on the direction negative for alpha 0. So this is it. Now we can click OK. We applied all kind of soil loads on our structure, and basically now we're ready to go on and to launch the analysis. To do that, you should go context check load data, setting data perform analysis and perform analysis, or you can also just click that. Okay, the program is going to work. Yes, let the program work. And there should be another window here in the center, but it is now going in another monitor for me, sorry. And okay, once analysis are ended, you're gonna see up there the two new contexts, so view results in order to just view results and check if the analysis are good for you. So the results seems realistic basically, and then the assign data context to do the verifies on the elements. First of all, we're going to do the geotechnical analysis and checks on the foundation elements. To do that, we should be in view results context. Click on the command context on the top left corner and go construction drawing generation. Here we should click RC plinth construction drawings. It states plinth, but it is the same command also for foundation piles. So click it, and nothing seems to happen, but the program basically creates the drawings on the design data, on the data folder of the project. If we go on the data folder, disegni. Okay, now we have these should be 8, so one for each plinth, for each pile. Yes, they're 8, and we can just open one of these with double click. Okay, this is the program that should be open right now. It is Procat Plinty. Okay, from here we have for every plinth its drawing with their bars number and computation. Basically, you have a drawing for each pile, but if they're all similar, and probably they are, you can go here on the right on Plinty Simile. I'm sorry, but it seems like this module, this program has no English translation, but don't worry, it's very easy to use. They're very low commands, so it's not should not be a problem. And so with this Plinty Simile, you can select all and click update, aggiorna. So it will unify, aggregate all plinths in the same drawing, like this. So before it was Pali 1, now it's Pali 1, 10, 11, so all piles are in the same drawing basically. Okay, so now that you have seen the drawing, we can pass to the design of the rebars. Well, this command basically are just graphics, and with this command pressure on the soil, I'm sorry, but I have a couple monitors, and you can see the momentum diagram, the on the pile on it in the wall depth. Close this with this command with the calculator. You can define the rebar diameters and number for the design. What you have here is the initial, so the minimum amount of rebars that the software is going to put in each pile. And as you see, it's also the defined quantity. So here we have stuff. We have phi8 on 12 centimeters between each other, and we have phi7, so a 7 diameter, number 16 for longitudinal rebars. That is the same that is stated here. So this is the minimum, as I said before. When we project with this command, of course, the program can put a couple more of that. If we think that just 6 rebars are okay, we can go down. If we are sure that it's minimum 8 rebars, we can modify this number basically, but I think you understand this is quite simple. And then you go click design, progetta. Okay, now he did this, so we can exit. You see that now the number of rebars changed. Before they were 7, now they are 16. So probably we should change something like let's have a try. We can go up with the diameter like 18, and with number let's go again on 8. Design, exit. Okay, now we have 13 rebars of 18 diameter. And well, basically this is it now. Then you can move like this in order to find your the configuration of rebars that you prefer. And with this command verifica armature, it actually do the checks, and it gives you back a calculation report. Well, these are various impostation that you can define for the checks. Here you have the regulation basically, so NTC or a Eurocode, and with OK. The program automatically gives you the report. Here you can go to the report. You have some tabs. In the first one, basically, here are reported the materials. Then there is a tab in which for each pile and for each combination you have the sollecitazioni, so orthogonal forces, normal forces, and bending moment and torsional moment. And then after this tab you have another one in which another couple, one for each plinth, in which it's stated for each combination if every check is basically passed, so it's okay or not verified. In this case they're all okay. And then basically we can go save relations, salva relazione, so save report. We go on the folder that we prefer, and we can go save. No, I'm not gonna do that, but you got it. And with this last command, computo metrico, you got the metric computation. It's very short, so you can basically select everything, Ctrl C to copy and Ctrl V to paste on the full report that you already saved. Okay, basically this is it for the Procad Plinty. After doing these operations, so once again, design rebars in which you select the number and diameter of rebars, and then the real check and with with the calculation report, and as last thing the metric computation. So once you do everything of this, okay, you can also save and generate the DXF file, so the real drawing. Clicking on this, you got this window. Here you got, okay, basically you have this PLN file. If you go back on the folder as before, we see that other than these .ply files, now we have a PLN file in which are included all the checks that we did before, and the software is using this to create the DXF file. So you got to select it, move on the right with this command, and then you just have to click generate file DXF. Once again, you have to select the folder, um, and then you can open it with AutoCAD or any CAD program you know. You're gonna receive exactly this drawing that you see here, just in the XF format. Okay, so this was all for this Blockad Plenty. You can save, you then go out. It asks you again to save before exit. Say yes. It's better to save twice than not to save. And okay, now that you have designed the rebars on the plinth, you you can basically go back on the geotechnical module with the design data, geotechnical analysis. Okay, give him a second to open it. Okay. And here, this is the same model that we saw before. First of all, we have to import the design results for the piles. So, we go on Calcolo, import armature e materiale pali. It means that this module, geotechnical module, will import the rebars that we created just a couple minutes ago. So let's do that. In this window, we see for each element its diameter, its length, and here we have the number of rebars, every parameter of the rebars that we already designed. We can also modify it if we prefer, and for example, if we use steel pies that don't need to be designed, if you click on this, you can just insert manually here the bending moment, the resisting bending moment to do the checks and then go assign. This is not our case, so we can go OK. And after that, we're going to do the checks also for either for superior foundations and for deep foundation. First of all, it's better to do the checks on the surface foundations. So let's go on Calculus, portanza fondazioni superficiali. Okay, it says that there are some unverified elements, but okay, right now it's not a problem. We go exit, and with this command, so with Calculus we actually do the calculus and the checks, and with this command we can see the results. So here we have stato di progetto, in which basically for each element it's reported if it is verified or no, and here we have portanza verticale valore massimo. Here it shows the maximum value for each element. It says not calculated. In this case, if we go scorrimento longitudinale, it's another kind of check, and so on basically. If we go on valore massimo, you'll see a map with all the structure. If we go all the results, select this, you can move between elements, and for each element check the various results. You have this menu. You can also go with the mouse rolling, or just click on the single element. Okay, after the superior foundation, we can go again on Calcolo and do the checks for the deep foundations like pies. Watch out that if you do this in another order, so if you go first with the deep foundation and then with the superficial ones, you're gonna lose the deep foundation results, and you have to do that again. So remember, first the superior foundation, then the deep ones. Okay, here calculus are okay. We can go exit, and as before, here we can check the project status. Okay, once again, they're not verified. Portanza verticale maximum value. You can just see here the map. and with all the results, tutti i risultati, you can check pile by pile, clicking on them, which are the results of the checks. Okay, so now we did the checks, and as output here we can create the calculation report with this command. So this is the window that is going to open, and basically here you can select which kind of report you want. First of all, on lingua you should click on English. And introduzione sulle teorie utilizzate, it means that at the start of the report it reports all the let's say the theory used for the checks. We're going to see that, and here you can click relazione superficiale, relazioni profonde, in order to create two different reports, one for superficial foundation and one for the deep ones. Let's try one of these. Okay, you see this. You see here you have all the math, all the theories that you have to know that the program used to check the single elements. It's quite a bit, and then you have just single results for each beam. So for each foundation, you have all the calculus that the program done. Once again, you can save it where you want, close this, and then from the same window you can go relation deep foundation, and it's basically the same. We have a different theory, of course, but the results are given in the same way. Okay, that's done. One other thing you can do here is with impostazioni. For each kind of foundation, you can define different kind of theories that you want to use to do the checks. So, of course, in literature we have different theories that you can follow in order to do that, and there are some available on the software, and you just can select which one do you prefer, and also modify some parameters in order to change the results basically of the calculation. Of course, as always, when you modify something, you have to go save. And now, okay, we're fine. This is everything for the geotechnical analysis and geotechnical checks on the foundation elements. So we can save and close. Every time you close, the software asks you to save again. So let's say yes. Yes again. It asks me where to save, but of course it's going to be in the data folder in the under folder geo. So yes, yes. And now once we close, we are back again on ProSAP. So what do we need now? We just miss to do the checks on the rest of the structure, and then to get the total calculation report and metric computation. So now we can move to the assign data context, and from here, in order to do the checks on the structure, we have to select all. So select everything, right click, design, limit states. Here you have to let the program work. If you click somewhere, you see the program not responding, but this is not a problem. Don't close it, just wait until it ends. And don't overclick around, because it seems to block, but it's still going on. And we received the warning that the software detected 3 elements which requires additional reinforcements. It's okay. Same for shear. And now from there we can check the design status of the limited states. But actually, it seems all verified. This is for shells, so for the free elements. This is the design status. If it's light blue, it means it's everything fine. And from here, you can check all different kinds of checks, like this. Then with this control inspect, you can click on the single element and check the situation for each kind of check. So axial stresses, shear stresses, and limit states. This is just a summary. And this inspect is important to go check the single elements. And instead for the foundation beams you can use this command. So basically these are the commands that are needed to check the status of the checks. And these with the A are for the tensioni ammissibili are for the admittable tensions, I think, which is the old way to to do checks. And this one with the L is for the limit state combination. So you generally use these. And this is for concrete beams, concrete columns, concrete slabs, so concrete slabs or walls, so the concrete D3 elements. This is for steel, timber, and masonry. Here we can check. Okay, we didn't design that. Why? Because I still had only the free filter. So when I click the select all, they were not selected. Okay, now I can do only the two, select all, right click, design limit states. Okay, so the program is now remembering me that it's usually better to first check the beams and then check the columns. But in this case, we can go, yes, we don't even have columns. And okay, well, this is not a good state for our structure, but doesn't. It's not important right now. The important thing is that you learn how to do the design and check the results with these commands. Here you have a lot of results that you can check. I suggest you to try it all, and if you don't understand some of that, you can just ask me by mail. But I don't want to lose much more time here anymore. We can go on and see how to obtain the total calculation report. So you need to go context and calculation report. Here in this window you can basically select which kind of results do you want in the calculation report. You have different options. Even there, I suggest you just to try them, then go watch the the report that you obtain and to see if it's good for you, if you prefer to exclude some parts, etc., etc., because it's quite variable here. You see that basically they are divided in groups. So here you have input data for material nodes, D2 elements, G3 elements. So here you'll have basically a list of everything that is used to prepare the model, and here you have analysis results. With this button here, you can print results by combination or by load cases, and the one that you read here is the one that is working. So with that active, you'll print for load cases. If I click and it became print by combination, it print by combination. And then here you have the results for the design, the two and the three elements. You have two different kinds of report, a calculation report that it's quite extended, and a summary report that is a summary. But I suggest to use the calculation report because the summary report is a feature quite new in the program and in English could not be exactly the best. The calculation report instead is the old way to do the report, and for sure it's better written in English. So okay, just you click there, you decide where to save it, and once it's saved, you can actually just check it. Okay, you'll see this window stating which parts of the report are written. But actually, I checked all the parts, so it takes quite much time. But usually, like input data, it's not really required, and so times will be shorter. And note that this report does not include checks results about the foundations that we generated instead with the geotechnical module. So in the end, you have to merge the two different reports into a unique one. Okay, it says that it's done. It should open automatically on Word, okay. And yes, from here you see this is the report. You have an introduction, and basically here you can find anything. Probably I forgot to check the English part, so calculation report, okay. You have absolutely to do this, so to change from Italian report to English report. Okay, I'm not gonna do that again. Just remember this. So we can close this one. Okay, the last thing we need to check to do is to obtain the design for everything else except foundation. You can do that by using the inspect command, clicking on an element. Never forget about filters. If I click on an element, I have to do export check draw well slab structure drawings. When you click it, it's going to open the ProCAD ZCA. And from here, as before, basically you can add additional rebars. With this command, you can see the status, the required area of rebars. So now with this command, you can basically add rebars where it's needed. Like in this case, we see that we have a need of additional rebars maybe in these areas. And so we can use this command, inserisce armatura integrativa, select an area in which we want to insert it, and insert which the rebars that basically you want with this diameter, this the spacing between them, etc., etc. If you go OK, now you see that you have a different, maybe I placed too much in it, but what I wanted to show you is that with this command you can add rebars and modify basically what's the check, what's the status of the wall. And then when it's everything done, when you're fine with your results, you can go generate file XF. Of course, you should save before. And as for the previous, as we previously did, sorry, with the pile foundations, you can just select the file, add on the right, and go generate file XF. You have to do this basically we can with every wall, but in a faster way you can with context go construction drawing generation and reinforce concrete wall slab construction drawings. Doing that, you will receive no message, but you know that the program prepared the files for the drawings. So when you go again check and draw, yes. Okay. Here, when you click General Dix file, yes, here you see that you have other files.set. So you already have them. And if you select all and move to the right, when you'll generate file DXF, you'll find each wall on the same file. Of course, this is suggested when you're okay with the design result. If you have to modify each single wall, it's better to do it one by one. And okay, I think this should be everything. And for the view results part, as I said in the previous lesson, I suggest you just to try to check the results and to see if you understand anything. If you have any questions, just ask me by mail. But you didn't have any question for me from the last about that from the last lesson, so I think everything is fine. And okay, this should be everything for this lesson. Once again, if you have any kind of question, just you can just ask me by mail, and I'm gonna answer you as soon as possible.